All right, guys. Thank you for being here again today. I was a little late because I had some things that I need to take care of before coming to office hours. We are on the next assignment, and what is that next assignment? It is Circles Quiz 2. Okay, so unfortunately, these quizzes are not synced, meaning like not everyone has the same exact questions. So there's going to be some slight variations, but the types of problems that you will encounter are all going to be very similar. Okay, maybe Kelvin, I want to have you go to Khan Academy and then share your screen with everyone, and then we'll go through like your quiz and everybody else. Okay, you're going to use those questions, okay, that are being presented, and you're going to model off of that. Cool. All right, so you're going to go into Khan Academy and you are going to pull up your particular quiz. Everyone else should also have their quiz pulled up, and if you run into any questions, okay, regarding like the first question, second question, third question, whatever, okay, you can interject and you can say, hey, Mr. Chan, can you take a look at my question here, and then see if we can go over that one together, and I will do that. Okay, but we're gonna start with Kelvin's. Okay. Hey, morning, Michael.
Good morning, Mr. Chan.
So so you're gonna go into Khan Academy. Okay, everyone is gonna go into Khan Academy, and you are going to go and look for this assignment here that says Circles Quiz 2. Circles Quiz 2. And then you're going to do a present screen. Cool?
So the exercise is Circles Quiz 2, right?
Yes.
Mind explaining to us why you were so late?
You're late if you say to someone, you're going to be there at a certain time and you don't show up. But I made an announcement. I told you guys ahead of time that
Okay.
but I had some things I needed to take care of.
Okay.
Third time.
What happened, Emmett?
I think Emmett is saying that we were all
What
here,
pushback to
but because you weren't here, some people left. Like me and Kian left before
No,
you
no,
arrived.
Okay. That's not what you wanted to say, Emmett? Okay, so we have here, convert the angle theta, which is equal to 310 degrees, to radians. Okay, so because you're asked to convert this, the formula that as we had gone over in past lessons, let's take a look at it really quickly again. So the formula that we had covered to convert from degrees to radians was something like this. So remember, x is equal to theta, or actually I used beta, right? Beta is equal to theta pi over 180, right, to represent radians. Remember that? So in this case here, you have 310 degrees, right? Whoops. So you have 300. So theta here is in this case is 310 degrees. We're going to perform that substitution there. Kelvin, can you tell me what to write? So if I know theta is equal to 310 degrees and I'm looking for beta, can you tell me how to perform the substitution? Kelvin, you're muted. So you're going to take this and substitute it in there, right? So what will that get you? Can you tell me just what to write? You don't need to figure out what the numbers are.
Theta over 310.
So it's 310 pi over 180. That's all it is. Okay? So if you look at this, right, 310 pi over 180, okay, is there a common factor between the numerator and denominator? Like, is there a number that divides into 310 and into 180? Can you think of a number that divides into 310 and into 180? Do you notice that there's a 0 right here, right? What does that 0 mean?
It's multiplied by 10.
Yeah, it's divisible by 10. So this is going to be 31 pi over 18. That's all it is. So it's 31 pi over 18. That's how we convert from degrees to radians.
Got it.
Wait, go back.
Oh,
Yeah, the quiz for me is a little bit different.
you're all going to have some slightly different questions. So you're going to have to rely on some of the things that we've gone over. Okay. So Michael, for yours, okay, what's your first question?
It is saying write a formula. I need to go to it again.
You're good?
All right. Good.
You want to do the second one? Or Michael, are you okay with the first one?
I'm going to it right now.
Oh, wait, can you guys hear me now, or
Yeah.
can you not hear me?
I can hear you.
Okay. I was going to ask you, why'd you have to delay the start time of the meeting?
Oh, I had some things I needed to take care of in the house. That's why. And I just couldn't. It couldn't be wait.
Okay, understandable.
He did give us the warning. I stupidly didn't check my email, because normally when I'm in a thing for like 5 minutes, there's normally an explanation for why the teacher isn't there.
Yeah, like I actually asked, maybe his computer is faulty, because something like that happened with our family circle with Senior Charter. Her computer was faulty, so she couldn't log in. But anyway, I have my problem. It says, write a formula for S in terms of R. So it says R, and then central angle is 1.2, and then S. The angle in the figure is the central angle in radians.
Can you share your screen?
Okay. So Michael,
Share screen?
when you yeah, share your screen.
Okay. Entire screen. Nope, not this one. My entire screen, please. All right, now do you see it?
Yeah, that's the one I have right now.
So look, that question right there, they're asking you to write a formula, okay? That 1.2, what is the meaning of that 1.2?
Central angle in radians.
Central angle in radians. How do you find arc length? if given the central angle in radians and the radius. We've gone over this. There's a formula associated with this.
Pi over 360
No.
equals pi over 180.
No. Guys, if you don't remember this, you got to write this down. So there's a formula. They're using the letter S here, right? So I'm going to use the letter S as well. So they're saying S is equal to arc length. And the formula was this. S is equal to beta times R, where beta, what is the meaning of beta again?
Theta.
No. Is beta the central angle in radian or in degree?
Radian.
Radians.
It's a central angle in radian. This is the central angle.
Oh yeah, beta. Yeah.
In radians.
Now
Okay. So right now,
back to me.
they're asking you to write a formula, right?
Mm-hmm.
They're asking you to write a formula for what? For arc length or for radius?
Radius. It says here at the formula for S in terms of R. The angle in
They're
the
asking
figure.
you to write a
the central
formula
angle in
for
radians.
S in terms of R. So Michael, what's beta in this case?
1.2.
1.2. Someone just finished.
I think that was Emmett.
Yeah, me too.
No, I finished that yesterday. That was something else.
Okay.
Okay.
So S is equal to 1.2 R.
Oh,
Right?
okay.
That's it. That's all it is, because it's asking you to write a formula describing the arc length in terms of R, right? That's all
Okay,
it is.
got it. All right.
This one is Calvin's right now. The one that I have.
All right, Kelvin. So can you present your screen? Or maybe Kian, can you present your screen if it's the same thing as Kelvin's?
I mean, Calvin already has his, so
You have to switch to it.
I have to switch to
you
it?
guys have to pin his video
Okay.
if you want to see it.
How do I pin your presentation?
It's a little pin thing on the. I think you pinned it right there. Oh no, you had it pinned. You had it pinned.
I had it pinned. Okay.
There you go.
That one,
Hi.
yeah.
All right. So it says here a circle with area 36 pi has a sector with a central angle of 11.6 pi radians. Okay. So now they're telling you what is the area of the sector. And now they're asking, oh, actually, no, I take that back. They're giving you that the area of the circle is 36 pi.
Mm-hmm.
And you're asked to find out what is the area of the sector here. Okay. So I'm going to quickly just write this down, and then we'll do it together. Who else out there has the same question aside from Kian? Anybody else?
Not me.
I'm pretty sure I had it yesterday when I did it.
It looks very, very similar.
Oh no, we had something very similar to this in the
In
Radian
the exercise. Yeah,
Yeah.
I agree. So the area of the circle is 36 pi. The angle is 11.6 pi. Okay, so I want to present my tablet. All right, guys. So this is the situation that we have right now. The area of the circle here is 36 pi. The central angle measures 11 pi over 6. Okay?
Yep.
So if you think about this, right? 11 pi over 6, okay, is the central angle, and it's in radians right now. Okay? Wait a minute. 11 pi over 6, okay, is to, what is this equivalent to? Let's do a quick conversion, okay? Because I want to figure out what is the area of this shaded region here, right? The shaded region here.
Yeah.
Okay. And in order for me to do that, I need to figure out what fraction, okay, of the entire circle is that shaded region there. So there is this one fact that I need you to be aware of, okay, and that is this. So in radians, right? If I have 360 degrees, okay, if I want to convert this to radians, what do I have to do again? I want to convert 360 degrees to radians. And I'm going to explain why I need this in a moment, okay? But can someone help me convert 360 degrees into radian?
2 pi radian.
360 degrees is equivalent to 2 pi radians. That is right, okay? And if you're wondering how Michael was able to figure that out, he just did the conversion by doing this, right? This is the same thing as 2 pi, okay? It's a 2 pi radian. Why am I doing that? Well, that is because if a full circle has 2 pi radians, okay, and the circle right now, at least the shaded region, okay, is 11 pi over 6, all I got to do is do this. 11 pi over 6 over the entire circle, okay? What is the full circle radian again?
2 pi.
2 pi. This should be proportional to the area of the sector. This should be proportional to the area of the sector, which I'm going to call x, okay? Divided by the full area of the circle. What's the full area of the circle?
360.
56 pi?
36 pi.
All right.
Okay?
Wait, is that a 36 or 56?
That's a 36. 36.
That's 36.
Oh.
That's 36 pi right there, right? So from here, all I got to do is just now figure out what that proportion is, okay? What is x? Okay, so how am I going to do that? Well, actually, I'm running out of room here, so I'm going to add another page. Hold on. This thing. I'm going to move it down. Okay. So I have this right now, okay? And what I'm going to do, okay, is I'm going to start simplifying that fraction. 11 pi over 6 divided by 2 pi, okay? 11 pi over 6 divided by 2 pi. Anytime you have the same things in the numerator and denominator, okay, what happens to those pi's there?
You could cancel them
They
out.
cancel out.
They cancel out. I'm left with 11/6 over 2 is equal to x over 36 pi. How do I divide fractions? Well, again, don't be intimidated. 11/6 times, what am I going to
1/2.
multiply by?
1/2.
1/2. That's all it is. And I'm going to multiply 11/6 and 1/2 here together. And if I do, I'll end up with 11/12. Michael, you're so good at this. What do I do to solve for x?
Cross multiply. So
Cross
it's
multiply.
12x equals 396 pi.
396 pi over 12 is equal to x, right?
Yeah.
And and actually we could have done something else. Instead of multiplying 36 and 11 like Michael did, right? Which he is right for doing that. There's something else that we can do. What number divides into 36 and 12?
3.
6.
Oh, 6.
That's right, 6. And 6
Whoa.
goes inside of 36 how many times, Ty?
Goes into 36 6 times, and it is 12 2 times.
Excellent. Right. And is there another factor that you guys can see that we can still eliminate even more?
Yeah,
12.
2.
12.
2. Right?
2.
2 goes inside of 6 how many times?
It goes 3 times.
3 times, right? So it's 3 times 11 pi. Or x is simply 33 pi. Again, the trick, if you want to call it that, okay, for this problem, is to recognize that this proportion that we're setting up, this guy right here that I'm highlighting, right, over the entire circle should be equal to the area of the sector over the entire area of the circle. So that idea there, okay, still holds. Any questions?
Can you please enlarge it? It is so small.
It is so small. Okay.
Yeah.
So I want to enlarge it.
Oh, perfect. Now I can see it
Right.
better.
So again, that right there, okay, is the heart, okay, of that problem there. If you are able to set up that proportion, everything else, okay, is just minor detail.
Got it.
Okay.
Got it.
So when you get down to it, and when it all boils down, what it all boils down to is this. We're left with the area of the sector, okay, that blue region there that is shaded in that diagram is equal to 33 pi.
So the area is 33 pi. Got it.
The area is 33 pi. Awesome. Can you want to do the next one?
Sure. I think it was the similar problem to what we did before. I have to convert the angle theta equals 9 pi over 5 radians to degrees. So I'll share my screen right now.
Okay.
Can you see it?
Can you zoom in? Awesome. All right. So 9 pi over 5 in radians to degrees. Let's do it. Okay. So really quickly now, can you, or actually, I can pin my presentation, right? Let me see here.
Cool screen, Kian. I like the blue text. It has a neon feeling to it.
Thanks.
You're welcome.
I have to pin my presentation. Is that right?
Yep.
Yeah, you might as well.
It's currently Kian's is dominating. I haven't even pinned his yet, but Kian's is dominating.
Yeah. Also, Kelvin, are you done presenting? Oh, you're not. Okay.
Okay. So you know what? I will just present on my screen and then hold on.
Did you get it?
All right. So what I need you to do for me is tell me the radian measure, right now is 9 pi over how much again?
5.
9 pi over 5. So Kian, is this theta or is it beta?
This is beta.
In this formula here. Is
This
it theta or is it beta?
Wait. So theta is
Theta
is
is in
degrees.
and beta is in radians.
Beta is
So
radians. So we're taking it to degrees. So in this case, it's theta.
So wait. Is 9 pi over 5, answer this question, is it theta or is it beta?
Beta.
It is beta, right? Is that what you said?
Yeah.
Okay. So that means we're solving for theta here in this case. So I have 9 pi over 5 is equal to theta over 180. If we have the same things on the left and right side of the equation there, with there being pi, right? What do I do with that?
Sorry, repeat that again.
If I have the same things left and right of the equal symbol there, right? Do you see that I have pi on both sides?
They cancel out.
They cancel out. So I get 9/5 is equal to theta over 180. I need to cross multiply here. So theta is equal to 180 times 9 over 5. How many times does 5 go inside of 180?
36 times.
36 times. So what I need to do is say, oh, this is the same thing as 36 times 9. Or theta is equal to
144.
A little more.
Oh, it's more than 144. Wait, hang on. 70, but 36 times yeah, that's 36 times 4. So it's 288 plus 32. That's
314,
12.
I believe.
Oh, 14.
Yeah.
Yeah, it is. Yeah, that's what it is.
Okay. Wait a minute. No, it's 324. I take that back.
Right. Yeah.
Okay, so theta is equal to 324. Kelvin, you want to do number 2? Or you want to do number 3?
Okay, this one I actually have.
Okay. Kelvin, you want to present yours or no?
Nodding. Yeah.
He's nodding yes. Okay. And then Ty, I'll let you present yours next. Okay.
I think I already did quiz 2.
You did quiz 2 already?
I'm pretty sure. Yeah. Let me just double check.
Okay. Kelvin, is this you? What I'm seeing right
Yeah,
now?
that's him.
Okay. So it says an arc subtends a central angle measuring 2 pi over 3 radians. What fraction of the circumference is this arc? Okay. So 2 pi over 3 is in radians. Okay. What they want you to do is to describe what percentage or what fraction, okay, is that arc length to the overall circle. So check this out, right? So you have the circle, and right now in this circle, this part right here, this part right here, okay, has some arc length, but they're telling you that this angle is 2 pi over 3. Okay, so 2 pi over 3 over the entire circle. What is the radian measure of an entire circle again? Like, how many radians is there in an entire circle? We just established this a moment ago.
2 pi.
It's
Yeah,
2 pi, right? 2 pi over 3 over 2 pi. This proportion will give you, it will equal to the proportion of the arc length, which I'm going to call S because they used the letter S, okay, in these examples here, over the entire circumference. They will the fraction of the radian measure of the central angle will be proportional to that fraction there, okay? So I got to just, sorry. So what I got to do with this, okay, is to simplify S over C. And again, I have pi both top and bottom. They cancel. I'm left with 2/3 divided by 2. And anytime that you're trying to divide fractions, 2/3, right? We got to multiply by the reciprocal. So I'm going to multiply 2/3 by
1/2, which equals 1/3.
So it's 1/3. So this is the fraction that they're looking for. What fraction of the arc length to the entire circumference will this be? It's going to be 1/3.
Also, Mr. Chan, yes, I did do quiz 2.
Oh, you did? Awesome. Awesome. Okay. Michael, do you want to share yours, or are you okay?
Go back.
Yeah, what was the answer?
No, hold on. Go back.
That was 1/3. Let me go back. It was 1/3.
Got it.
Michael, are you doing okay there?
Yeah, I'm doing okay. So you're
Okay.
presenting screen right now, right?
Are you presenting right now or no?
No, there's something wrong with my headset. Can
Okay.
you-
So maybe we'll we'll go over another one of Kelvin's here, and then we'll do the next one.
Sure, no problem.
Okay. So it says, what is the area of the? Hold on. So it says a circle has a sector with an area of 24/5 pi and a central angle of 48 degrees. What is the area of the circle? Okay. What is the area of the circle? So just don't do anything yet. I want to quickly write this down. So the sector is 24/5 pi. And the central angle is 48 degrees. And we have a situation that looks like this. And you're asked to find out what is the area of the circle. Okay, so I want to present. Okay, so you're asked to find out what is the area of the circle, given the situation right now. So the area that's in pink right now is 24/5 pi. The area that's in pink is 24/5 pi. And this angle in here is 36 degrees. You're asked to find out what is the area of the circle. Okay? So let's try to figure this out, okay? In order for you to find the area of a circle, okay, what is the one dimension that you must have? When you're finding the area of a circle, you always have to have one very special number. What number do you have to have?
Pi?
Well,
We already have pi. We already have
pi
pi.
is a constant, and that is known. But what is one dimension? What is one physical length that you have to know in order to find the area of a circle? You have to know one specific length.
The radius?
The radius. You need to know what the radius is, okay? So in other words, in order for us to find out what the area of the circle is, you need to know what the radius is. So I think 2 days ago, or was it yesterday? It was yesterday. Seems so long ago. So yesterday, I went over with you guys how to find the area of a sector, right? And I gave you guys two different formulas, one of which was 1/2 beta times r squared. Remember that?
Yeah.
Yep.
And then the other formula was 1/2 theta pi over 180 times r squared. Okay? So right now, okay, what you guys have, okay, what we're dealing with, okay, do you think we should be operating with that first formula here or the second formula? What do you think?
We should
Given
do
the
the.
situation.
I think we should do the second formula.
I agree with you, Ty. We should definitely use
Yeah, I'm with Ty.
Why? What's giving you that? What's suggesting that?
Because we'll have pi on both sides, so we can just cancel them out.
We have pi on both sides, but there's also one other really important thing here that's given to us. That's also suggesting why we should use that equation highlighted in yellow. It's this thing right here, right? That angle measure right now is in what units?
Degrees, right?
It's in degrees. That's right. Okay, so I'm going to use that second equation there. So area right now, okay, is what number do I substitute in for A?
We substitute 24/5 pi.
24/5 pi. Very good, Ty. Is equal to 1/2. Okay. What do I substitute in for theta?
48.
48. And then times r squared. Remember, our goal is to figure out what pi r squared is equal to, right? So actually, if we are able to isolate this thing that I'm highlighting in pink, we would get the area of the circle, right? So check this out. What's 48 divided by 2?
24.
It is 24. So I'm left with 24 pi over 180, okay, times r squared is equal to 24 pi over 5. Anytime you have the same things on both sides of the equation, what happens?
Cancel out.
They cancel out. What can be canceled out at this point?
24 pi. 24 and pi.
24 and pi. These two things can cancel out. Okay, so I'm left with 1/5 is equal to r squared over 180. I need to now find out what r squared is. What do I do?
Cross multiply, which means
Multiply.
5 r
That's it.
5 r squared equals 180.
So r squared is 180 over 5. 180, 5 divided into 180 how many times?
36.
36. That's what r squared is equal to. So therefore, the area of the circle will equal to how much?
36 pi.
36.
That's it. So proud of you guys. This is so good, right?
Thank you, thank you.
So that's how you do that.
Okay. Got it.
How many questions are there on this quiz?
There's 5. But
There's 5. How many have we gone through now?
Like 6, but I still need to finish one more question.
Wait, so are there 5 or are there 7?
No, there's 5, but everybody has a different set of questions.
Okay.
Yeah, let's do Kian's last one.
All right,
Yeah.
Kian. You want to present yours?
Yeah, give me a sec.
No problemo, senor.
Because we're quickly running out of time here. This will be the last one
Yeah.
for today. We'll pick this up tomorrow, okay?
Sure, no problem.
Can you guys see?
Yeah.
Yep.
So it says convert theta, which is equal to 180 degrees, to radians. This one's a quickie, okay? So let's think about this. Okay? 360 degrees into radians is how much?
2
well,
2 pi radians.
2 pi. So 180 degrees then. 180 degrees then, okay, is how many radians?
1 pi.
Pi.
1 pi. That's it. That's
or just
all it
pi?
is.
Just pi?
Just pi.
Just pi radians? Nothing
That's
else?
it.
Wow.
Wow.
Do you understand why?
That's fast.
Well, that was the last one. You finished it?
Yep.
Awesome. All right. So, how many questions, Michael? How many questions do you have left?
4.
Okay.
Yeah, 4. Okay. So tomorrow when we pick this up, we're just gonna jump right on with yours. Okay. Kelvin, how many questions do you have left?
1.
You have 1 question left. Okay. And Ty, you finished. Emmett, you finished
Yep.
also?
Yeah, I'm good.
You're done. You're good. Okay. So we're gonna pick this up tomorrow. Okay. We'll start with Michael tomorrow. And then we'll oh, and Preston, were you able to get things done?
Yeah, I finished, but I got a couple wrong, so I'm gonna redo it.
Okay. So tomorrow when we come back in, we'll pick that up. Okay.
All right, sure.
Everyone here should get ready for Family Circle.
Yep.
All right.
Okay.
Take care.
All right.
Thanks,
I'll
Mr.
see
Chair.
y'all. See ya.
All right,
Bye.
Bye.